Chemistry 1 students, Mr. McKay here, showing you a few mistakes that are common to students as they start balancing equations. A couple examples I think is the easiest way to start this. So let's say I have potassium chloride. I'll write the formulas for you on this video. And you're reacting that with fluorine gas. And you're going to make, in that process, potassium fluoride and chlorine gas. And I basically give you the instruction to balance. Common mistake that students make. Always it's coefficients in front. So when we think about what's happening here with different compounds, this is potassium chloride. That's what it's called. So I can't, because I have two chlorines on the right hand side, just throw a 2 on there. Okay, that's not allowed. I'm erasing that. You cannot do that. Okay. Same thing with the fluorine. I'll go back to my original color here. Just because I have two fluorines that have to be stuck together, remember these are, the subscripts sort of tell you how things are bonded. So fluorine gas is it's called a diatomic molecule. It is bonded to itself, and I can't erase this 2 or add things to that. That is by definition what fluorine is. For the same reason, I can't just say I'm going to make that compound no longer potassium fluoride but some new thing which I don't even know what that is. So we cannot do these things. Just leave these alone. Right. So what can you do? Or another thing that students do, I should go back first to what you can't do, is some students will want to do this. All right, well, I see that, but maybe I can, or students will think this. I've seen students do this before. This is bizarre to me, but here's what happens. If I haven't already written the formulas for you and I say, all right, what does that react to form? I'll have students do this. KClF2. They'll just make one giant jumble of those things and put them together. Realize that in chemistry, it's about taking atoms that are the same kinds of atoms on both sides and rearranging them to form new compounds. Potassium finds a new partner up, basically. Instead of chlorine, it forms potassium fluoride, or forms a partnership with fluoride. All right, back to what we were talking about. Another thing you could do is a common mistake. Let's use a different reaction now. You could possibly have this one. What if we had sodium metal, plus oxygen gas, forming sodium oxide? And again, by doing crisscross and all those things we learned earlier in the course, you would get all these formulas. What I can't do, even though it's very, very tempting, is add a 2 right there. Can't do that. How do I take care of the 2? Another possibility, I've seen people do this. Throw a 2 right there. Can't do that. The only place that I can put the 2, again, since it's a coefficient, let me redraw that. The only place that I can put the 2 is there. Now, in doing that, that gives me 2 of this whole thing. Think about this as a whole thing. But it gives me 2 oxygens in that process, but it also gives me now 2 times 2, or 4 sodiums. Well, you know what's nice? Over here, I got sodium by itself. So by doing that, I can go back now and fix my sodiums. So that's what the balanced equation is going to look like for that one. I'm going to go through in the next video and talk about the helpful hints that will keep you from doing the wrong thing. But bottom line is, it's always about coefficients. And that equals the big numbers in front. The end. Thanks for listening.